my name is Dory, and today I'm here to present on the impact of data path cycle speed performance. In this presentation, we are going to understand the relationship between clock speed and instruction execution. So, in this presentation, we'll get to know what CPU data is. Aside that, we'll consider the stages of a basic CPU. We'll also get to know how clock speed affects CPU performance. Also, we have diagrams to show literally everything about this presentation, and we also have a flowchart diagram. So to begin with, we'll talk about what what CPU data path is. So we have the fetch, and the CPU places this address on the address bar and fetches the information via the data bus. Aside that, we have the decode, and the decode is to identify the operation to be performed, and these operations involve arithmetic, logical, data transfer. We also have execute, and the execute in the CPU performs the operations specified by the instruction. Depending on the instructions, and it may involve arithmetic logical operations, which is handled by the arithmetic logical unit, that's the ALU. Also, we now proceed to the stages of a basic CPU. So, a typical instruction in the CPU goes through several stages, and the first is the instruction fetch, which is the IF, and is responsible for fetching the instruction from memory. Also, we have the instruction decode, the ID, and this decodes the instruction to determine the operation. We also have execute. The operation is performed in this stage, and the examples include arithmetic operations, which is like the ALU, the arithmetic logical unit, as we discussed earlier. And we have the memory access, and data is read from or written to the memory. Also, we have the write back, and the result is written back to a register. So these are the stages of a basic CPU, and here there's a diagram to show how everything works from the beginning to the end. So the fetch is the first, then the decode, then the execute, then store. So we'll now proceed to how clock speed affects CPU performance. So clock speed is measured in hertz, and it determines how quickly the CPU can complete a fast cycle. So this is how it works. Faster clock speed results to more cycles per second and more instructions executed per second. So a faster clock cycle means that the CPU completes each instruction faster, and when it does so, it improves the overall performance. We also have visual, the diagram of two CPUs, one with 1 gigahertz clock speed and the other with 2 gigahertz clock speed. So to show how the 2 gigahertz CPU completes more instructions in the same time period, then you label the two CPU speeds, the 1 gigahertz, which is the slower with fewer instructions, and the 2 gigahertz, which is the faster with more instructions. So that's the difference. The 1 gigahertz is slower and has fewer instructions, and the 2 gigahertz is faster and has more instructions. So this is how the clock speed affects CPU performance. So cycle time versus instruction execution. We also have the title, which is the relationship between cycle time and instruction execution. We also have bullet points, and the cycle time is the duration of one clock cycle. And the shorter the cycle, the quicker the CPU and can complete an instruction. So this is how it works. Faster cycle time, decreased latency, and that's the time taken to execute a single instruction. We also have more cycles per second, so higher throughput, and throughput is the time taken for a complete cycle to perform its tasks. And yes, we also have visual, the bar chart comparing cycle time and the number of instructions executed, and the exercises which show the time cycle, the short versus the long, and the y-axis, which is the instructions executed per second. So pipelining and clock speed. Yes, so pipelining is just how faster cycles enhance instruction, and the bullet points. Yes, so we mentioned this earlier. in the previous diagram. So we'll just, yes. So these are all related to how the clock speed affects CPU performance. That is just basically what we're talking about. So this is our first diagram. So it shows where to start from. Then the instruction fetch, the decode, the register fetch. And we have the memory access instructions. Yes. The branch instruction, the jump instruction, the R-type instruction. This is another diagram to demonstrate the fetch, the decode, and the execute. And the flowchart diagram too is here. So this is the end of my presentation. And I hope as you watch this, we'll all be able to know more about data path cycle, the CPU, how the stages of a basic CPU, and also how the clock speed affects CPU performance. Thank you.